One last customized printer to look at. So I'm going to introduce you now to Johnson. Hey Johnson.
Hello.
How's it going?
Good. How are you?
And our great friend 3D Alley.
Yes, this is the 3D.
What's Alec all about?
So this is a printer that we built for the clinical collaborator at Sydney RPA Hospital. So all of the components were built in-house, and this printer is able to print 3 different materials, each having their individual printing speed and conditions. So we sort of tailor them to be able to print different materials that require different printing parameters.
So like all of our other customized printer projects, of course, driven by a real clinical need, and usually always actually by a passionate clinical collaborator. So tell us a little bit about our passionate clinical collaborator on this one.
So this printer was designed for the project where we regenerate the cartilage of the ear. So it's in patients with what's called microtia, and that's in the normal development of the normal ear. So what happens is that the ears, when the child is through the growing stage, they will have a deformed ear where they only have a little bit what's called a peanut shape ear. So it's different from a normal size ear, and the current techniques to treat that requires a lot of surgical process and leads to a lot of complications. So the passionate clinical collaborator came to us looking for a bioprinting solution. That's where we came up with this idea to print the entire ear out of biomaterials.
Right.
Yeah.
And so of course, that passionate clinical collaborator is Pal Mukherjee from the Royal Prince Alfred Hospital. So this is obviously quite complex, right? Because you need I'm guessing, a material that's going to retain structure, mechanical integrity, and another material for growing cells, and in your case, cartilage. So I guess that's why we have this multi-head printer that's been necessary for this project.
Yes, as you can imagine, if we were to just print an entire ear scaffold out of a gel-based material, it's not going to hold shape. And the ear is all about the aesthetics. So that's why we needed materials that give it the structural support, materials that give it the cell support, and then obviously a sacrificial material which is required for all 3D printing applications. That's why we have this complicated printer where we have 3 heads, one that cools down, 2 of them that cools down, and 1 of them that heats up the material to allow us to do melt extruding.
And so we've developed this with our clinical collaborator who's helped us to articulate the challenge and then develop the plan and put that plan in place. Where are we now in terms of transferring this into the clinical research environment?
So as you can see with some of these scaffolds, they come with different pore sizes, different orientations, and each of these different patterns correspond to a specific stiffness and flexibility, just like the normal ear, what we experience in the normal ear. So this is sort of the first phase of a project where we try to represent each of these regions by changing the parameters of the printing process. Then the second stage is then to incorporate cells in there and induce chondrogenesis, and which is what we're trying to do right now, inducing chondrogenesis in each of these different patterns and hopefully each of these regions because of the different stiffnesses and mechanical properties they would produce allow these chondrocytes to excrete out different amounts of matrices.
So obviously a very multidisciplinary project, bringing together material scientists like we've met today, and process engineers as we've met today, and mechatronic engineers and biologists and biomaterial scientists. I'd imagine that projects like this are both challenging but extremely rewarding. More challenging or more rewarding?
I would say a bit of both. It's definitely very challenging as the ear isn't one uniform stiffness as we can see. It's a whole range, and then we have to make sure select inks that are not only printable but also compatible with the cells, and that's sort of the challenging bit. The rewarding bit is once we can introduce this new concept, then we sort of solve a lot of the issues that we have currently in surgery where they have donor side mobility. And so this is a lot easier in terms of the whole printing process.
Well, we've had an exciting journey around our labs today, starting with fundamental advances in material science and how we're using chemistries to retain all of those amazing properties we discover sometimes in the nano world of materials, and bring those through into processing structures like the sutrode, and making devices like for the ear and the cartilage regeneration, and blending together all of the skills necessary to do that. And of course, working very closely with all of our collaborators who are real end users. And here at Tricep, being able to complete that pipeline to take everything to that manufacturing level, the bioink that can be manufactured, the printer that can be manufactured, and all of those solutions delivered to our end users. It must be a very interesting experience to be involved in here at Tricep.
It is. Over here, you can actually put your projects, the research project, into practicality, into a clinical scenario, and that's what's exciting.
That's what we're here for.
Yes.
Cheers.
So yeah.